Sudhir, I'll turn it over to you.
Thank you, Lauren. Good afternoon. I'm Sudhir Shrestha with Office of Water Protection Geointelligence Division. I lead Web and Data Services Program for OWP. I just wanted to welcome you all. This is our first API webinar for partners. We're very excited about it. Just to give you a little bit of context around the National Water Protection Service. So for almost like more than 2 decades ago, Weather Service has delivered water resource products and services via Advanced Hydrologic Prediction Service, you all are aware of. So this legacy system actually was developed like sort of old technology now, right? And then the infrastructure that needed to be modernized so that we can support better and newer innovation and technology that actually supported by service-driven architecture. So for doing so, just to give some context around it, we just couldn't move AHAPs into the cloud as it is. So we had to do the total rewrite of our code base to take advantage of the newer, to support the newer capabilities on the web dissemination. So we're also trying to make sure that the NWPS infrastructure is guided by high uptime and failover options. So National Water Protection Service is a new next generation our gateway to water services forecast information on the web. And this future leaning dissemination platform transfers how we disseminate hydrological information to the public and partners. So this NWPS project involves our really close collaborations and detailed feedback coming from our partners and stakeholders that is helping us to complete this moving of our AHAPS functionality into a lot more modern and efficient data dissemination platform now we call NWPS. So moving forward, the web delivery platform will be, NWPS will be our primary platform for the source of information that we provide for the data and forecast information. Just to give you a little bit context around like the web content on our web page that we'll not talk a lot about it, but just to give you context around is that in NWPS is driven by a current and newly developed the web and data services that can be leveraged directly by our partners through NWPS application program API. So API that's we'll be talking about today. So basically all the users will be able to consume the data via machine to machine readable data that will be coming from our partners as well. So without taking over, I just wanted to introduce our presenters today. We have Crane Johnson, who is a hydrologist with Alaska Pacific Region Forecast. And we also have Paul McKee. He's the Chief of Hydrologic Services from Weather Service, our Southern Region headquarters. And we also have our contract support who has been helping build this application from they are the Orion Network Solutions Field Camp, and the Tim McCalmet is also present here. So without much ado, I would like to just pass it on to Paul McKee to get started. Paul?
Sorry about that. Can you hear me?
Yes.
Great, thank you. My apologies. Anyway, welcome. Good afternoon. As we get started here, I just want to welcome a variety of people here to the webinar. I know we've got some internal staff across the National Weather Service, technical staff, as well as external partners, and we value both of you, and that's why we welcomed you both to the call today. The main objective here today, ultimately, is to introduce you to the API services that are driving our new system, and the purpose of that is so that as developers, you guys can begin to make the transition in your scripts and processes from the legacy AHAPs into the new system. So that's why we're here today. But in a little bit, we're just going to give you a quick overview of kind of the project ultimately of migrating what we're calling legacy AHAPs to the new National Water Prediction System, which is yet another acronym, NWPS. So you've already heard Sudhir using the acronym already. You'll hear it a lot through this presentation, but NWPS does stand for National Water Prediction Service. So we're going to overview that, and then Crane is going to take over from there and walk you through the application program interface, or our API services. And with that, it's going to give you a few use cases, some examples, and some discussion around that in terms of how that would look for you as an end user, bringing the data, into your tools and applications. And then we want to talk to you a little bit about how the partner and public testing is going to move forward and the schedule we have for that. And at the end, we'll have a Q&A session. With the Q&A session, please feel free to through the webinar to add questions to the chat. We've got someone online that's going to compile those questions, and at the end, we'll take them one by one and attempt to answer those. If we're not answering that question in the way that you can understand, please feel free to continue to chat, because we want to get this right today. So with that, we'll begin with the overview. So ultimately, what we're talking about here is what we're kind of calling either a migration or an evolution of our legacy AHAPS, which was the Advanced Hydrologic Prediction System, to a new system, and we're changing the name with that. So we're ultimately moving into a complete rewrite and new architecture with AHAPS. Sudhir mentioned that AHAPS is built on 2 decades plus technology and servers, and it was in need of not just a web presence facelift, but a server. So we're moving this system to the cloud. So what most of you are familiar with is what we call AHAPS, and that's the water.weather.gov location that you've been used to going to, getting all your hydrologic services information for the last, again, close to a little more than 2 decades. And we've had some transition within AHAPS through that period of time, but you're going to see kind of a new facelift from that. In addition to just the rewrite and the migration, we're also including, with the stand up of our Office of Water Prediction and the National Water Center, we had an entire new web presence of products and services that are coming. And so it was time to essentially merge the two together. So what we're talking about here is a rebuild, a migration, and then merging our collective water web presence and the way that we deliver data by way of services. And so all that's coming together in what now we're calling National Water Prediction Services, or NWPS. You can see the link on the bottom of this slide. We've got a story map put together that kind of gives you a good overview with that. So when you get the slide deck, you can hit that link. It's a great kind of presentation to take partners through what I just described in a little more detail. Next slide. So in a nutshell, and again, I failed to mention, well, I did mention, our objective is toward developers today and the API services and the OGC geospatial data services that drive everything you see today. And we've had webinars already to kind of take a deeper dive into the project and the transition. Some of you partners have already, well, at least I hope many of you partners have heard that the transition to NWPS was coming. Some of you may not had that deep dive webinar yet, but that's coming. It'll be done through locally and regional levels at a later date. Some of you have seen those at conferences, presentations given already. But in a nutshell, with NWPS, what we kind of started with, pen to paper early on with requirements that would drive not just the migration, but the rewrite, was that it be mobile friendly. And so we've got a mobile friendly interface. Everything you see either on the phone or on the web is going to be geospatial and API driven from data services. And we wanted that because we want our partners, who ultimately, whether it's internal or external to the agency, to be able to leverage these data services into their own tools and resources. And so we're really excited. That ultimately, for me, I mean, that was, well, those were the top two: mobile friendly, and let's get this thing data service driven. And so you developers on the call probably know what I'm talking about when you can understand the pains of maybe of getting information maybe from legacy AHAPs, and to some degree, having to scrape the web service to get the information that you needed. We've also we're now hosting this on a scalable cloud infrastructure. So we've got a modern platform for dissemination. So those are the three big ones on the back end. What you're going to see, I'm pausing here for a second. I lost video. Okay. Does everyone see the screen now? Hope so. Okay. So those three bullet points are really kind of more on the back end, but what we've also got is some improved features and user navigation that comes with certainly all the the bells and whistles of the latest technology with respect to geospatial data display. We've incorporated those into the web map. At this point, you can now see current and forecast status within the same visual display. Many of you that may be familiar with some of the River Forecast Center web displays, they've been doing that for a while, but we never had that feature available on AHAPs. So now that ability is there to see those simultaneously. With our gauge pages, we've got enhanced hydrograph pages. You can access both static hydrographs still, which was a feature we've had that we retain, but our hydrographs are also dynamically driven as well, that update almost instantaneously. You'll still be able to see all the flood stage and impact information on a hydrograph page as you did, including probabilistic graphics, and the inundation maps were available. So we've got with the National Water Model, and many of you seen presentations over what we're doing through the National Water Center with the National Water Model, but it's giving us stream flow guidance at about 2.7 million river reaches. And so we needed a way to incorporate that as well within the new system. And so now we can actually see hydrographs at those locations within the same system as our legacy AHAPs. NWPS will also give us the outlet again for the National Water Center Prediction Operations Division, which is our operations division of the Water Center. As we get new products and services coming out from them, this website will be the platform by which we can bring those to you. So the deployment date here is Q2 of this fiscal year for the deployment. We'll be talking more about a timeline here in a minute. So with that, I'm going to turn this over to Crane, and Crane's going to talk us through the API.
Yeah, thanks a lot, Paul. And if you can just give me a thumbs up if you can hear me okay. All right, sounds great. Yeah, thanks everybody for joining us. As Sudhir and Paul covered some of the general background of the API and sort of how it was developed and how it came about. Just for those that in the audience that maybe aren't developers that use APIs regularly, API is a collection of web services with parameters that are provided that allow systems to integrate data. We've probably all used various APIs through the years. The NWPS API will actually be a tool that we use to drive the National Water Prediction System. So we've built it for ourselves and then make it available to partners and third-party application developers to leverage in their systems as well. We expect people to pull our forecast information and use it in their visual displays. To the right is just a quick example on how APIs can be leveraged. In this case, it's a hydrograph and it's got observed data from USGS. It's got river flow forecast information from the National Weather Service. And then in the background, flow statistics from the USGS. And so, it's a great example of multiple sources integrated. And that's what we expect. We'll be using our API for our own system, and then we expect partners to use the API to integrate data, forecast data into their own systems. Next slide. A quick look at our legacy system, the AHAPS, and I would sort of describe that as a variety of endpoints or not available at all. And so we had CSV file listings that would get used occasionally internally. We provided for each river gauge an XML file that was available externally. But if we've all tried to sort of query AHAPS gauges, we know that some of the things on the AHAPS web pages weren't available through the XML. And one great example and one important example are the flood impacts. And so those were within an HTML table, but not available through the XML or through any other sort of automated data endpoint system. Under the new National Water Prediction System, we'll have full API access to both the data and metadata. So anything displayed within the NWPS platform will be available through the API. And so we'll have a few places within the presentation and we can post it in the chat, but that's just a link to the new NWPS API just below the image on the right. And the goal is that external users and our own NWPS web app will be leveraging the API. I think moving forward, this will just provide a great way to integrate our data with other agencies' data for both our own systems and for partner systems. Next slide. Just a quick look at available APIs on the left. We've all probably worked with USGS Water Services. It's been an amazing API available for at least a decade or more. Stable. They've got a custom, it's well documented with a custom interface to generate your custom URLs. And then some of the newer APIs from USGS are the National Streamflow Statistics Web Services that also provide sort of great, well-documented interfaces. The NWPS API is going to be based on the OpenAPI 3.0 standard, formerly known as Swagger. So that comes along with a set of standards and tools that make it consistent with other projects that use the similar OpenAPI 3.0. So you'll get some similar features that you expect across various APIs, and all of these are RESTful services. Next slide. So I'll briefly just mention the National Weather Service also has an operational API with a link there and the link provided. And that's an operational API that provides basic weather information for users that aren't aware. This will be a second API complementary that provides information for the National Water Prediction Service. And so what we've got there is the landing page for the Swagger documentation page that we'll go through and describe briefly just to introduce it to both hydrologists and developers in the audience. Let's go to the next slide. And what I'll do is I'll share my screen, and the goal here is to and if, Paul, you could confirm I've got the Swagger screen shared. Okay, so you can see it.
Well, actually, I'm sorry, Crane. I'm seeing the chat. I'm seeing the chat window. You've got your chat tab.
Let me try to share that again. I think how about now? I think we've got it.
Yeah, Crane, that looks good.
Okay, perfect. Thanks. Sorry about that. So this is the landing page, the documentation page for the National Water Prediction API. Few links at the top, email link, and then a link to the National Water Center. And what I'll do is just go through briefly and describe some of these various endpoints for the API. The 5 at the top here under the heading gauges generally relates to actual stream gauges that are out in the field. And then there's 2 more API endpoints below that labeled reaches, and they both are related to the National Water Model guidance that it's available. So I'll go ahead and click this and expand the first API endpoint. And so this is how you would retrieve a list of gauges. Right now, the only filter we currently have available is a bounding box. And so if you wanted to select, say, all the gauges within your state or county, you would come up with a lat-long bounding box that would just capture the information for your state or county. Sort of one guiding principle with all APIs is that we'd expect developers and users just to request the minimum amount of information that they need for their application and at a minimum frequency that they need for their application. So we would request that folks limit bounding box requests to just the, say, the county, the state, water science center that they're interested in. For all of these endpoints, you can test them right here online through the documentation page. And it's simply just select, try it out. All the text boxes become live. And then at the bottom, you can hit execute. Within the gauges endpoint, it'll provide you what is comes out for each gauge. And so you can do a request, say, for Pennsylvania, and you'll get a listing of every active gauge within the state of Pennsylvania. And it'll provide the latest observed stage, the latest observed flow if available, and then the crest forecast stage. Along with those, it'll also provide the current observed flood category, so whether it's minor, moderate, major, and then it will also provide the forecast crest flood category. So it'll give a user a quick snapshot of the status, and this is what's used to generate the map displays within NWPS. So I'll go ahead and minimize that. The next endpoint is the gauges with the identifier included, and just like it says in the label there, this provides the gauge and all its metadata. This is one of the most important endpoints that's available through the NWPS. So I'll go ahead and I went ahead and pre-populated the National Weather Service location identifier, PTTA4. You could also enter a USGS identifier as well, and then just hit the execute button. And what I'll do, it provides, one handy tool with this Swagger documentation. It provides the curl command if you wanted to automate these data requests. So for scripts, other systems that you plan to have automated requests, those can be, it provides a pre-built command. The other thing it provides just below that is a request URL. And so if you had a JavaScript front end, this would be the request URL to get that information to another web app if one was developed. It provides standard service response codes. And then what I'll do is I'll scroll through the response of the body and just highlight some of the key features that are within this gauge metadata. It's basically, think of all the information that wraps around the hydrograph on the current AHAPS page. And so it's got a forecast, recent crest, historic crest, impacts. So right here in the top, we get the gauge ID and then the corresponding USGS ID. And then one thing that I'll highlight right here is the reach ID. And so that corresponds to the National Water Model reach ID. And so if you wanted to retrieve the corresponding water model guidance with one of the other endpoints, you would use this reach ID. As we go down through, there's more metadata. The flood categories, so those are available through the API. Historic crests. I'll continue to scroll and just capture a few of the highlights. Recent crests, and so if you're familiar with the AHAPS pages, these are both tables within the page.
Hey, hi, Crane. Quick note, sorry to interrupt. So I think if we can make the font a little bit larger, can we do this? Yeah, increase it. Yeah.
There we go. Thanks, Sudhir.
Yeah, better. Thank you. Yeah.
So one key thing, I think, one great improvement with the NWPS API is that the impact stages will be within the API. They were not available programmatically through the AApps. It was just an embedded HTML table. And so this will be an advantage for any users that'd like to query these into their system. The other thing I did want to highlight was that while the new system is all driven with dynamic data and dynamic graphing, we do retain the old static hydrographs. And so for each gauge endpoint, you'll have a default URL for the standard hydrograph and then a second URL for the hydrograph scaled to flood categories. And so I think that's important for users to understand that that will be retained and the URL link will be within the gauges metadata endpoint. So I'm going to go ahead and minimize that. And because this gauge endpoint is so important, I'll go down and show that within the documentation, there's the data models are described. And so as you look at the endpoints and the data, the information that you retrieve, you can go ahead and look at the endpoint model and you'll see that each of those fields is described. And so as I mentioned, the reach ID, and that's the National Water Model reach ID. So for all the data models within the API, each one's got a description below, and occasionally they'll reference some of the other data models that are available. So back up here, we'll walk through a couple of the other endpoints. I'm not going to demonstrate these. This next one here is you provide a identifier, USGS or National Weather Service site identifier with the ratings at the end, and that'll give you the forecast rating curve. So the rating information that would be used for our forecast values.
Hey, Crane, sorry to
Yes.
pause. Can you do maybe a Control Plus and increase the font on your browser? Maybe. There you go.
There we go.
Thank you.
The fourth endpoint below is stage flow, and so that's where we provide the data. And so that second endpoint, the gauges with identifier, provides the metadata. This fourth one, the stage flow, provides the observed and stage per particular gauge. And I'll just click the get button. Similar to the other endpoints, to test it, you would just select the set active, enter an identifier, and hit execute. And for this one, it simply provides the very short information metadata. I think it's location and a few other fields. And then the primary values returned are the observed stage and flow and the forecast stage and flow. And as with each endpoint, you are provided with the curl command to embed in, say, a shell script and or the request URL if you wanted to query it directly. And so these can just be cut and paste into your browser to get a first look at what that endpoint would provide. And it'll be the same as you get within the Swagger documentation here, just usually not color-coded. Just to note right now, all of the endpoints return JSON data. That's the standard that we have. And so it's a well-formatted, structured data format that most developers, advanced users are familiar with. This last endpoint within the gauges, still related to actual string gauges in the field. And so this one is if you wanted to just grab the forecast information or just retrieve the observed information. So it's a subset of the endpoint that's just above it. And so similar to the rest, you could hit the try it out button, add an identifier, and then you would select observed or forecast information and execute. And then the return information would be both in the window below, and then the curl and the URL commands will be provided. We'll go ahead and minimize this endpoint after it loads. And so just to reiterate, all the gauges endpoints basically cover string gauges in the field. So you'll get your metadata, and then any information that was available through the AHAP's website or will be available within NWPS should be available through these endpoints. The reaches, two endpoints, they're related specifically to the national water model. And so there's two basic functions. One's to get metadata for a specific water model reach. And so what we would do is hit the try it out button. We would enter a specific reach ID that we can get from the gauge's metadata. And or for sites that don't have a corresponding gauge, there'll be a method on the NWPS. Once the full NWPS website's public or in testing phase, you'd be able to select on a map and retrieve the reach ID through the website and then use it through the API. Reach IDs aren't expected to change, and so you'd be able to save that as that reach ID for that particular location. Same thing with the previous endpoints. The curl command is available, and then the request URL. And then we'll just look at the response body for the National Water Model Guidance endpoint. And so it provides just the name of the river, lat long, center point for the reach. And then these are the available streamflow guidance time series. And then it provides a little bit of reach navigation. So you're provided with the upstream reaches, in this case 2, and then a downstream reach, in this case 1, with the National Water Model Reach ID, and then also the stream order within the hydrofabric for the National Water Model. So we'll go ahead and minimize this one, and then we'll hit the get button and expand the streamflow endpoint. And so this is where you would actually request streamflow for a particular reach. And this is the National Water Model Guidance. So we'd hit try it out, enter a reach ID, and then we're provided with the time guidance time series available from the National Water Model. And we'd hit execute. And then we provided with the same simple metadata. And then in addition, we're provided with the, this would be the medium range guidance outlook information. And so we've got a time series of times and flows that correspond. And so those will be available through the National Water Prediction System in a secondary display. The primary display will be the RFs, or the official National Weather Service forecast information, along with observations similar to AHABs. So I'll go ahead and close this endpoint. And then the 3 endpoints below are, at this point, for internal use. They'll be available external as well. For us, the one here that's listed as stage flow with identifier and then a PEDTS code, that would be to get a specific time series related to AHAPS or NWPS hydrograph. Currently on AHAPS, the PEDTS code is provided in the bottom left. And so that's a bit of an internal tool if we wanted to request one code or the other. And then the last endpoint will be used for internal monitoring data status for the new NWPS API web services and website itself. So I think with that, we will go ahead back to the presentation, and I'll go through a few case studies or example use cases and just how they would be implemented in the new API. And I'll just maximize the screen. So the simple use case study would be, say, if you're within a county and you wanted to have an application that captured and monitored the latest data values for all sites within your county. Like we mentioned, we've got one filtering mechanism right now, and it's a bounding box. And so, for some of our applications, we'll be using the entire domain. But what we expect is the example below would be the bounding box for Pennsylvania. And so it'll be a latitude, longitude provided for Pennsylvania. And in this case, 463 gauges were returned with a file size of about 265 kilobytes. And then on the right is just an example of the gauge data model. And so what you're provided is the latest observed stage and flow, and then the forecast crest and flow as well. And then for both observed and forecast, a flood category. So in this case, action is the gauge was currently in above action stage, and then the forecast had it rising above minor flood stage. And so this could, with the latitude, longitude, could be translated to a map view or just pulled into a local application that provides at least sort of could be tabular status for all the gauges within your area of interest. So we'll go ahead to the next slide. And that just highlights the key information. So one thing that developers out there have probably been leveraging is the current XML file. It's a well-structured data endpoint that provides information for the AHAPS gauges. And so to grab the same information within the NWPS system, there would be 3 asynchronous calls. One would be to the gauges endpoint to get the gauge metadata, which may be less frequent. And then the second request would be to request the observed and forecast information from the stage flow endpoint. And then if needed, if the forecast rating was needed, the third request could be the ratings endpoint. And so we'll go to the next slide. And this just shows an example. The old method was a single request to the XML. We described it was limited, not all the information on the AHAPS pages was available. The new method would be a minimum of 2 asynchronous API calls. One could be less frequent depending on the metadata. Wouldn't change as often. And then the stage flow, typical update would be at least hourly for most USGS partner gauges. And so that would be requested separately. And then the rating would be if needed for the forecast information from that third endpoint. And so those are all just example endpoints. Go to the next slide. So this would be, something that we'd expect people to do, and that's just to build a hydrograph similar to what we will be doing in the NWPS web app. And that's the same basic request. You would just request the gauges endpoint for the metadata to describe flood stages, if you wanted to add flood stages to your hydrograph, if you wanted to add impact stages to your hydrograph. And then the second call would be to request both the observed and forecast information. And next slide. And just a visual representation of building a hydrograph with an example gauge down in Texas. And so everything within NWPS, that's just a snapshot view of what NWPS will look at, is just driven and built by these APIs. And in this case, it's 2 data calls. As I mentioned, within the documentation review, the existing static images will still be available to both partners and developers. Next slide. So and then the last use case would be the national water model. And so in this case, it'd be 2 data requests. One would be to request the reach simple metadata information at that top left there. And then the second one would be to actually request the, could be the assimilated information, which is historic. And then it could be the model guidance output, which would be into the future. And that's just a quick screenshot of how that can be incorporated along with the gauges metadata to present the information, on a hydrograph with additional impact stage information, impact or flood stage information. Next slide. So I'll pass it off to Paul. That was just basically, we wanted to have a brief introduction to developers and hydrologists within the API, and we'll cover some of the GIS cloud services and then check in on the schedule and feedback towards the end of this presentation.
Yes, thanks, Crane. So in addition to the API services that Crane just described, our web mapping display is also driven by OGC compliant REST Cloud services. And maybe many of you are already familiar with what we would call our IDP GIS services that had recently been transitioned to the cloud. And so in the upper left-hand corner there of that slide, that web address will get you to all of those cloud services. And in particular, in a little subset there entitled Water are a listing of ones that are available currently within those cloud services. And let me point your attention in particular to, well, to two of those. One would be that all of the AHAPS, what we would call our AHAPS river gauges, or are actually stream flow locations where we offer forecast services. Those points and the metadata is all available there in a geospatial data service for plotting. In addition to that, with the legacy AHAPs, we had the ability for some locations to display flood inundation mapping, and those maps have all been moved to cloud REST services as well. And so that's the link there. In addition to that, so that's our IDPGIS kind of moved to cloud services for the Weather Service. For the National Water Center, also has a host of services that we're calling HydroViz, and those are also cloud services. And so all of the new kind of products coming out from the National Water Model, and the flood inundation mapping, et cetera, will be hosted under HydroViz, and that REST service link is available there in the bottom left. And so I would encourage you just to, you can quickly hit those links and explore those and get a quick understanding of everything that's available there. But just want to, highlight the fact that our experimental flood inundation mapping services that we just released for 10% of the U.S. Population are there, in addition to many others derived from the National Water Model. And so definitely explore that. They're all available to pull into your own, web mapping displays or applications for use. And so we're excited and proud that those are available. It's been a lot of effort put into making that happen. So with that, we'll transition back to Crane. It's gonna kind of cover the timeline with us, and then we'll move on to Q&A. Crane.
Hey, thanks, Paul. So this is a sort of current overall schedule for the NWPS deployment. We're on the left here with the Partner API webinar today, November 7th. And then as of today, the API will be available for development preview through the preview URL. The top blue line just covers the AHAP's current system, and so that we do plan to discontinue that in April 2024. Below the bar for the API available for development, we'll have a few other things that occur with the NWPS website. There'll be an official 30-day testing period for the NWPS itself, and then we'll have a period of updates for both NWPS websites and the API before the planned operational implementation of the NWPS website in the later part of March next year. And so if we go to the next slide, I'll just highlight some of the sort of key schedule aspects for developers and users of the API. The 30-day testing period will begin when NWPS is previewed to the public. So that'll be this month. It's available now, but when this official 30-day testing period starts, the API will be fixed for that 30-day test period. And so that'd be the time to provide input, feedback, suggestions for enhancements. Once we get through the 30-day testing period, the API will continue to be available with bug fixes and possible API updates during this period. And so that'll be available through when we go to NWPS operational. And so the preview-api.water.noaa.gov will transition to api.water.noaa.gov. And so at that point, to go from development scripts that use the preview API to the operational API will be just a simple URL change. So we'd like users to keep that in mind. And then the existing AHAPs will continue to operate with the current functionality at least 30 days after NWPS goes operational. And so there will be some overlap between AHAPs and NWPS for users. But now, the focus for developers, say, to leverage the current XML would be to transition to use the API to pull that same information for your applications. Next slide. And so I think at this point, we'll take questions. I believe Paul is going to lead those. We'd like to request all users test the service, and then we'll keep this email up there, nwps.support@noaa.gov for questions and feedback after this webinar and throughout the testing period, all the way up through and into when NWPS becomes operational.
Yeah, thanks, Crane. Yeah, let me just reiterate that we desire your feedback, and it can't be too minor or too big. So please take down the email, the support email there at nwps.support@noaa.gov. That'll be your avenue for providing feedback or asking questions about the services as you're testing. And so we've collected the questions during the webinar here. I want to go through those. So the first question was, will ensemble forecast probability ranges be something that may be toggled on or off? Crane. And we may have to get some context, further context around this question.
Can you repeat that, Paul?
And so will ensemble forecast probability ranges be something that may be toggled on and off?
Within the API?
Yeah. So no, I think not in the API. I don't think you're able to do that, right? But if it is just a question for the websites, that's another context. But from the front end, you can, right?
Okay, that was Eric B at NERFC. Eric, if maybe in the chat you could provide a little more context, and we can and we'll go on to some other questions, but we'll come back to you. We want to make sure we get this question right. So next question, will we be able to get the data for the forecasted points in the hydrograph? Not just the max forecast level, but all of the ordnance or all of the points, to be able to show what levels may be 6 hours out, 12 hours out, et cetera, at the gauge that we can plot on a map. Crane.
So the simple answer is yes. And so, any information that's displayed on AHAPS will be available through the AHAPS, and then NWPS will be available through the API. So the full time series, forecast time series is available.
Thanks, Crane. Next question is, will the PowerPoint be available to reference in the future? Absolutely. We are making a recording of this webinar, and it will be available in a YouTube video later on, and the slides will be available in a PDF version. Next question. What reach-based variables from the National Water Model will be available through the API? Example, can we get more than just the stream flow values for the medium range ensemble for a reach? I'm curious if the velocity data that you can extract from nomads will be accessible. Crane, are you aware, or anyone want to take that one?
Yeah, I'll take that one, and maybe Sadir could help out. Currently, what you can expect is what's available through the documentation. So it's limited to the guidance values. I expect the API will continue to grow and mature over time. And if we've got use cases or requests for particular variables, we would evaluate those each individually in the future.
No, definitely. Thanks, Crane. I think we'll welcome the feedback, and also if you can help us with some of the use cases, how you want to use that data sets, that will give us some context, and we'll definitely review those and then make that capability available to the API. So this is just like a first cut of the API that we're making it available, right? So based on our users how they want to consume the data sets, definitely, yeah, if you provide us some of those feedbacks, we'll make sure that those requests we can get into our development.
Okay, thanks. Yeah, for sure. This is another feedback, a feedback issue here too. Please provide that feedback via the support email. Next question. When will the KML stream gauge observations stop being available? I assume there will be some grace period between when the new API goes live and when legacy products are retired. Crane?
So I think we can, they'll stop when AHAPS is decommissioned. So right now that's scheduled for approximately a month after NWPS goes live. I guess one follow-up for that is that some of the existing GIS web services, map services may cover those needs that exist now.
Thank you, Crane. Next question. Will the URLs like this remain for hydrographs and the static images? And I think that was asked and answered earlier in the chat, but we'll cover that again here. Yes, the static hydrographs will remain available. And we put in the chat, I believe, the URL where those hydrographs will be available, but it's a PNG formatted hydrograph file.
And one comment on that, Paul, I think with right now, the static hydrographs are provided from a preview endpoint. And so that will change when we go operational, but that new endpoint should be described correctly within the API operational endpoint.
Right. So normally the format will be that they will not be preview, but the rest will, the link will stay the same.
Okay. Next question. Let's see, is the URL going to stay as is moving forward, at least for the next few years, or is it just the evaluation period? And I think we've covered some of that already, but the preview URL is definitely during the testing feedback phase. Once we go live and operational, the URL will structurally will be the same, just minus the preview dash in the URL. Anything else to add there, Crane or Sadir?
No, I think that's a.
Paul, there was a follow-on to this question about how someone can confirm when it's been taken out of preview mode. Like, is there a way to track that status? So maybe we can do that now.
Yeah, thanks, Emily. Yeah, Sadir, that question was asked in terms of how to track when that moves from preview mode to the standard URL.
Yeah, so that we'll send that out email as well. So our public notice will also go out. So normally, like, that link will change when we go operational. We're expecting on the end of the March. So we'll have a public announcement going through that because we'll be at the same time here as well. We'll providing the public notice as well for 30 days to get the feedback from the public as well. So that's when it will stay for 30 days. After that, when we go operational, and we'll send out the official notice, and then that link will change.
And
But-
Sadir, I'll just add, that'll be advertised widely on the existing AHAPS webpage with banners.
Yes, that is correct. Yep. So we will provide those into the AHAPS as well. So those information in AHAPS, yeah.
Okay, thanks, Sadir. Is there any plan to move some of the geospatial information into GeoJSON format? And our developer on the call here has responded, yes, as the API matures, it will incorporate more geospatially enabled information. So, and we'd like to hear that in your feedback as well. Again, anything that you guys think that is missing, we want to hear it. One of the things recently we've been talking about internally is just kind of that aspect of the unknown unknowns, and you, our external partners can help. We want to see what we can't see, so please provide the feedback. Next question. I'm a data provider to AHAPS. How will the data format required from us in the new system change? Is there any changes with respect to data providers as far as providing data?
So I think we need a little bit more context, what kind of data sets you will be providing. But normally there shouldn't be any change how, on the data format that we received in this, but like, maybe we need a little bit more context, what data.
Yeah.
Yeah, I
So,
think in the, go
yeah.
ahead, Crane.
Yeah, I'll just, for any river gauge data providers, there'll be no change in the data ingest. So if it's something else that's maybe provided to AHAPs, but if it's a river gauge in the field and a partner that provides data, there'll be no change to the data ingest.
Yeah, thanks, Crane. Appreciate the clarity there. Next question. Is HADS or Chef NWSLIs with reported stage information a downstream or upstream of WHPS? For example, NWSLIs found in HADS Chef without any entries in WHPS.
Paul, I think that question is related to maybe a site that's reported through the National Weather Service HAD system, but maybe not be displayed on AHAPs. And so that would be a question for the local weather forecast office that maintains that gauge would be in their area of interest.
Okay, thank you. I think maybe Daryl Hertzman asked that question. Daryl, if there's any extra context there, please add that to the chat. But yeah, likely depend on data type, data quality for sure. Next question. Looking at the data from gauges, for example, VRVC1 stage flow, the ID is not in the JSON. Also, how do you know the actual time zone since it's listed as PST 8 PDP? Anyone want to take that?
There is a response, so I'm not here on, I think. If you want to take it.
Yeah,
So
I'll
I'll just,
Yeah,
go
Lori.
ahead, Crane. Yeah, I think we may have to investigate a particular location if with the time zone parameter. Over time, this is going to expose a few things in our metadata that might need to be QC'd again by that local person in the weather service. So if you do see issues with information that doesn't look or seem correct, definitely use that email address for questions and feedback. And it could be that there may be some type of error in our metadata system that needs correction. I don't know if that's true in this case, but I did want to bring that up since it was a tricky question right off the bat.
Yeah, thanks, Lori.
I think,
And
and I
No,
think
Yeah, I
follow
see
up
there
on
are
that.
some feedback from Tim as well. So yeah, so what I'm reading here is like, I don't know if that is from Tim, but the correct ID is not present, but it is required to reach the stage flow endpoint in the URL. The listed time zone PST 8 PDT is the time zone in which gauge is located. Update and generated timestamps are provided in UTC. If you wanted to extend anything, Tim, feel free to chime in.
I think that's probably good for now. Let's
Okay. Yeah.
let's move that question. We can the question and answers will also be delivered with the video, with the slides. We'll continue to refine our answer to that. But whoever posted that question, please maybe open up a support ticket, and we would certainly want to be sure that we're following that. So thank you for the question. Next question is, will the API need authorization to use? It's currently, the API is public. You probably saw the little authentication thing up on the upper right. And so there's currently no endpoints that need authentication, but we have the capability to do that. And as the API evolves, we may begin to utilize that feature. Next question. Any changes planned for the AHAPS, KMZ, or shapefiles, or for gauge RRS files? Craig, do you want to tackle that one?
Once the AHAP's decommissioned, the plan is for the KMZ and the RSS files to not be available. Shape files will still be provided on the downloads page under the new system.
And I'll also add that in some way we hope our OGC REST service or cloud services will also in some way replace those shape files, or it's another option instead of using the shape files as well. Next question. Are the two GIS server URLs aliases? That way, if you move services to a different server,
No,
we don't
no.
need to update the URL links.
No, those are two different the services it serves. So one is for our partner FIM, another is for the other services from the water center. So those are two different data endpoints. So those
Yes.
are two different services.
Thanks, Sudhir. Appreciate that. Next question is, will the flow forecast be out to 5 days and with probability?
So I'll
Great.
just, the flow forecast, similar to the current AHAP system, the flow forecast is variable in length, and that's a user gauge defined value. And so that will remain the same within NWPS. So at the transition, whatever's available through AHAPs for forecast length should be what's available through NWPS. And that varies across the country by gauge.
Thanks, Crane. Next question. Will the process of downloading precipitation grids, such as QPE for the last 7 days, be changing when AHAPS is discontinued? Crane, Sudhir?
So it's a
ultimately the URL is going to change, but the same data will be available. That's ultimately the bottom line for that question. So the data will be available. At the URL to access it will change, and that change will be posted. Next question is, can you get stage and flow data for a specific date and time?
So I'll take that one, Paul. So at this time, similar to AHAPS, it'll be limited to a short window of observed data and then the current forecast information. And so within NWPS, that will be the same way the data is served. One big step forward for NWPS is that we'll have 30 days of observed data, which for partners and users, that gives you some time to go back and take a look at the hydrographs. Historically now, we've just been limited to what's displayed on AHAPS, anywhere from 3 to 10 days. And it will also be limited to the most recent forecast available through the API and as displayed on NWPS, similar to what's available through AHAPS at this time.
Thanks, Crane.
And
yeah,
then,
good point.
As with all river gauges, you can also, we generally serve the data and it's often collected by another agency, whether it's USGS or a partner state agency. And so they are the source to go to for archived river gauge information.
Thanks, Crane. Yeah, good point about going back 30 days now, and that'll be a huge benefit to our users. Next question. Any plans to add WFO, RFC, state querying, or filtering to the gauges API call, or will it just be limited to the boundary box? Crane?
Yes, the short answer is yes. We'd like to expand the available ways to query so that we can help users limit their data requests. And so the bounding box is just the first available filter. So we would appreciate feedback on a specific filter that would help you minimize your data requests.
Yeah, thanks, Crane. I could see maybe even FEMA region being another filter for that. All right, next question. Will it provide us with a reason for spike or rise in water? For example, it's obvious when it's raining or there's an ice jam, but when there's no reason, it requires a visual inspection. Usually it's just an anomaly. Will NWPS be able to detect and report gauge anomalies? And can it report that the gauge is not working properly to the user side? Green.
I'll take that. It'll be similar to how the data is presented in AHAPS. So there won't be any specific metadata associated with that. Often in AHAPS, if a weather forecast office sees some information, they can add a site-specific note below the hydrograph and or take a gauge out of service. But there'll be no additional functionality in NWPS beyond what you are familiar with in AHAPS.
Yeah, thanks, Crane. Yeah, and you mentioned the hydro notes on the hydrograph page is definitely something that could be added to make to give reason for the forecast. Next question is, will it be possible to access historical, not only current, stream flow forecasts? Crane.
No, similar to AHAPS at this time, it'd just be the current forecast that's available through the API endpoints.
Thanks, Crane. Next question, does the National Weather Service have any plans to change their QPF from text format to API?
Well, I think we don't have right now that we don't support that right now in our API. That's all I'll say.
Yeah, AHAPS hasn't historically supported that, and we don't have the QPF forecasts.
Paul, I'll follow up for that particular question. I'd suggest they reach out to the River Forecast Center that covers their area, and they could get some more information on the QPF forecast and maybe how that's shared out to other partners.
Yeah, good point. Thank you, Crane, for adding that. And that's currently being done. Yes, as you noted, partners are coordinating with the River Forecast Centers for QPF. Okay, that's the last of the questions I think that we've compiled from the chats. And my apologies that we've gone over time here. We know your time is valuable, but we appreciate you for hanging on. Again, this was to introduce you to the API services. We hope that it generates a lot of conversation, discussion, and questions. Please feel free to exercise the nwps.support@noaa.gov email for providing feedback and asking questions as you continue to explore this preview of our API services. So we appreciate your time today. We know we've got a collection of external partners and our internal staff. Both are critically important to our mission, and we appreciate your time over this. And we know this is going to be a process, and we're committed to walking this with you. So don't be bashful to reach out to get support on how to transition from our legacy AHAPS services to the new NWPS. So thanks again.
All right. Thank you. So I also wanted to take just a few moments to thank all of the attendees who came to spend time. We're definitely looking forward to your feedback. We'll appreciate the feedback. And definitely, if there are any specific use cases or the data that you're looking for, please let us know. Please use the email we have here, nwps.support@noaa.gov, and we'll note that down and have as a part of some of our future development that we can support. But even with that, I also would like to take time to thank our presenter, right, Crane and Paul, for such a fantastic job, as well as some of our support from the Orion, the Tim McCulmott and the PhilChem for supporting this work. And definitely, I also would like to acknowledge Lori Hogan, who has been helping us here on the back end side, and the Emily Steffen, both from the Weather Service Eastern Region headquarters, and our team, internal team, also the Chip Gobbs and Angela and Lauren and Michael, and our NWPS integrated working team who has been helping us get through all this process, definitely, and our NWPS team, all our for river progress centers and WFOs and all other our partners, and definitely appreciate everybody's support on this one. So we're looking, this is just a start, right? We're looking forward to extend a lot more to it. With that, thank you, everyone, and thanks for sticking around for 12 more minutes than our expected time. So appreciate everyone's participations. So, all right, thank you.